Hey everyone. In this video, we're going to take a look at some basic one-step equations, specifically how to find the inverse operations to solve for our variable in each equation. So here we're given an example of a basic one-step equation. It's x plus 5 equals 10. What we look for is what's happening on our left side, what's happening to our x value. So in this case, we have our x being added. It's x plus 5. All right, so the inverse operation for adding 5 would be to subtract 5. So what I'll do is I'll subtract 5, and because it's an equation, what I do on one side of an equation, I have to also do on the other side of my equation as well. So I'll subtract 5 on one side, a positive 5 and a negative 5 or a minus 5 cancels out, and then I'll go ahead and subtract 10 minus 5 on my right side, and I end up here with x equals 5. In order to check your answer, you can also plug it back in. If I want to take my 5 and plug it in for my x, if I was to do that, I could verify that I got the correct solution. 5 plus 5 would be 10. And we can see here that I would end up with the correct solution there. Okay, let's take a look at a few more examples. Okay, so here we see pretty much the 4 basic examples that you'll see here using addition, subtraction, multiplication, and division. So the first one here, letter A, we have kind of similar to the one we just did. It's x plus 3 equals 7. We notice that in order to get our 3 moved to the other side, we're going to go ahead and do the inverse operation. If I see a plus 3, I'm going to subtract 3 from both sides. When I do that, my 3's cancel out, 3 minus 3, and I get x equals 7 minus 3, which is 4. In B, we have x minus 4. It's on the right side of our equation, so that means that that's where we're going to be doing our operation. If it's x minus 4, the inverse operation to that would be to add 4. And again, I do that on both sides. Cancel that out, and I'll end up here with 13 equals x, which is also the same as x equals 13. Okay, moving on to the bottom. We now have multiplication and division examples. Our first one here is negative 2x equals 10. When we have a negative 2x or a coefficient attached to a variable without any sign in the middle, we assume that it's multiplication. So in this case, if I want to cancel out this negative 2 here, what I'm going to do is I'm going to divide by that same number, negative 2. We know that negative 2 divided by negative 2 is 1. So that's what we're looking to do when we're dividing. We're trying to cancel that number out, all right, by making it become a 1. So we divide by negative 2, that cancels that out. And then on the right side, 10 divided by negative 2, I'll end up here with x equals negative 5. And that would be my final answer there. Notice when I get to every final answer, my x value is completely isolated. It's completely by itself in each of my solutions. It's always x equals some numbers where you were trying to get to. And last but not least, we have a division problem here. In this case, we see a fraction, but again, you can understand that when we see a fraction, x over 3, that's the same thing as x divided by 3. So in this case, if I'm dividing by 3, my inverse operation would be to multiply by 3. And again, I'll do that on both sides. It's an equation. What I do to one side must also do to the other side as well. So here we end up with 12 equals x. 4 times 3 is 12. Or, again, we could also write that as x equals 12. That's interchangeable. All right. And again, we have our isolated x on one side, and we have our number on the other side as our solution. All right, so those are some basic one-step equations. Again, you want to kind of identify what operation is happening to the x first, and then use the opposite or the inverse operation to go ahead and solve for your x and get it by itself.